From the moment our ancestors first looked upward, the night sky has been a canvas for wonder. Long before telescopes, before mathematics, even before writing, the stars inspired awe and unease. Scattered lights across the darkness seemed too deliberate, too mysterious to be mere decoration. They became stories, God, warnings, and promises. Across cultures and centuries, humanity has asked the same question. Are we alone in this vast expanse, or do the heavens harbor others? In ancient Mesopotamia, the stars were not distant suns, but divine symbols. The Babylonians mapped constellations into calendars, linking celestial patterns to earthly events. In Egypt, the star Sirius guided the flooding of the Nile, weaving astronomy into survival. For the Greeks, the heavens were alive with gods: Zeus hurling thunderbolt, Artemis guarding the moon, Orion frozen in pursuit across the sky. These myths were not mere entertainment, they were humanity's first attempt to make sense of a universe that felt purposeful yet inscrutable. Across the world, similar stories flourished. The Navajo saw the Milky Way as a sacred pathway created when Coyote flung stars into the sky. In Polynesian cultures, star navigation carried voyages across ocean, blending myth with mastery. In China, the stars were woven into the imperial mandate, symbols of cosmic harmony or disruption. Wherever people looked upward, they found meaning, and in that meaning lurked an unspoken possibility. If the heavens are alive with gods and spirits, might they also be alive with others like us? As centuries passed, myth gave way to measurement. The invention of the telescope in the 17th century transformed the sky from a realm of symbol into a field of discovery. Galileo revealed moon orbiting Jupiter, undermining Earth's central place in the cosmos. Suddenly, the heavens were no longer immutable, they were worlds, dynamic and diverse. The possibility of others shifted from divine to natural. If Jupiter had moons, could it not also have inhabitants? Early astronomers speculated wildly, imagining canals on Mars and forests on the moon. The 19th and 20th century sharpened the question. With Darwin's theory of evolution, life was no longer miraculous but natural, shaped by laws rather than chance. If life could emerge on Earth, why not elsewhere? The cosmos, once populated by gods, began to look like fertile ground for biology. As radio technology advanced, humans attempted to listen for signal, to catch whispers across the void. Thus was born SETI, the search for extraterrestrial intelligence. Instead of reading omens in the stars, scientists now scan them for patterns, hoping for proof that we are not alone. And yet, despite decades of searching, silence persists. The Great Silence, as it is sometimes called, has become as haunting as the myths it replaced. Ancient peoples saw gods in the stars. Modern scientists hear only static. This silence fuels both skepticism and wonder. Perhaps we are alone, an improbable accident in a cold universe. Or perhaps the cosmos teems with life, but we lack the patience, tools, or perspective to find it. What unites myth and science is the same impulse, the refusal to accept that the sky is empty of meaning. Whether through gods or galaxies, omens or observatories, humanity has projected itself outward, seeking companionship in the stars. Each age has asked the question in its own language, but the yearning remains constant. As we follow this thread into the modern age, one truth emerges. Our gaze upward has always been a mirror. In the sky, we see not only distant lights, but our own hopes and fears reflected back. The search for others is also the search for ourselves, beyond space into time. When most people imagine extraterrestrial, they look outward. The questions is framed in terms of distance. How far away might they be? On which planet? Circling which star? Yet there is another possibility, one that shifts the search from space to time. What if the others we seek are not distant neighbors across the galaxy, but neighbors who occupy a different moment in cosmic history? Instead of living light years away, perhaps they live centuries, millennia, or even eons apart from us. Time complicates the search for life in ways that distance never could. The universe is 13.8 billion years old. Earth has harbored complex organisms for only a fraction of that span, and technological civilizations for less than a blink. If alien civilizations arose even 1 million years earlier or later than, our chances of overlapping may be slim. From this perspective, the silence we hear is not evidence of emptiness but of misalignment. We and they may simply be ship passing in the temporal night. This thought reframes the Fermi paradox, the haunting question, where is everybody? Perhaps the answer is not nowhere, but not now. Civilizations might flare into being and vanish like sparks separated by gulfs of time rather than space. Our radio telescopes may be tuned to listen during an intermission, a quiet stretch in a much longer cosmic play. Ancient myths, in their way, hinted at this temporal dislocation. The gods of the sky were not always present. They came and went, revealing themselves in cycles. Some cultures describe golden ages, lost epochs when divine beings walked among humans. These narratives, though poetic, capture a truth. Existence unfolds in era, and what is real in one epoch may be absent in another. Modern science echoes this idea in its recognition that stars, planets, and even life forms have life cycles. Nothing persists forever. The prospect of temporal aliens carries both melancholy and wonder. Imagine a civilization that thrived 1 billion years ago on a distant world, long extinguished by now. Their achievements, their stories, their struggles all gone, save for traces buried in cosmic archaeology. Or imagine a future species millions of years ahead of us, rising after humanity has vanished, looking at the stars and wondering if anyone was ever there before them. We may be alien to them, just as they are to us, each civilization stranded on different rungs of time's ladder. This perspective also reshapes how we think about contact. Traditional SETI searches imagine a conversation, a dialogue across space. But if civilizations rarely overlap in time, then contact may take the form of artifacts rather than messages, ruins on distant planets, technological fossils preserved in cosmic debris. Instead of listening for voices, we may need to look for echo. At the same time, time offers hope. Just as we may have missed others who came before, others might one day find us. Our signals, our spacecraft, our traces in the solar system may persist long after we are gone, breadcrumbs across cosmic centuries. To imagine being discovered is to realize that we too might be someone else's alien, not in space but in history. So the search for extraterrestrials cannot be confined to maps of the galaxy. It must also stretch across the timeline of the universe. Out there may also mean back then or yet to come. And in this shift, we are reminded that our existence, however brief, is part of a much larger unfolding. We may not be alone, but we may be out of sync, glimpsing the vast stage of the cosmos from our fleeting moment in its play. We often picture ourselves as lonely watchers, peering outward into the cosmos for signs of life. Radio telescopes sweep the sky, satellites listen for whispers, scientists analyze faint signals from distant stars. The narrative assumes passivity on the part of others. If advanced civilizations exist, surely they too are scanning, waiting, hoping for contact. But what if this assumption is naive? What if we are not the observed but the observed? This inversion is known as the observer's paradox, the unsettling possibility that extraterrestrial civilizations, perhaps far older, far more advanced, are already watching us. If they have mastered technologies beyond our imagination, they may not be limited to the present moment. They might manipulate time itself, observing humanity not only as we are now, but as we have been across history. To them, our search for life might resemble ants staring at the sky, unaware that the gaze has already been returned. Modern CT efforts embody humility. We broadcast, we listen, we wait. Our instruments measure light curves of distant stars, searching for the faint dimming that might betray alien megastructures. We assume parity, that they would need to reveal themselves in ways we can detect, that their presence would be symmetrical to ours. Yet history warns against this symmetry. Whenever two civilizations of unequal power meet, the less advanced is often studied, catalogued, and observed long before it comprehends what is happening. Why should the cosmos be any different? If time itself is pliable for such civilizations, the imbalance grows even more profound. Imagine beings who can look backward, peering into our past as easily as we flip through an old photo album. To them, our ancient myths and modern experiment are equally accessible, each moment fixed in a space-time they can navigate at will. From this perspective, our efforts to reach outward become almost quaint, a species searching for neighbors while already under surveillance. Skeptics argue this drifts too far into science fiction. We have no evidence that time can be manipulated, let alone that civilizations exist to exploit it. Yet physics does not dismiss the possibility entirely. Relativity allows for time dilation, wormholes, and scenarios in which time behaves less rigidly than we perceive. If such mechanisms are possible, it stands to reason that a sufficiently advanced intelligence might exploit them. To us, they would appear omniscient, watching from a vantage we cannot yet access. The paradox, then, is one of perspective. We assume we are the searchers, but we might be the search. Our role shifts from explorers to specimen, our transmissions less like greetings and more like signals from a laboratory cave. Even our silence speaks volume. The chemical signatures of our atmosphere, the glowing web of our cities, the electromagnetic haze leaking into space all reveal us, whether or not we intend them to. This inversion unsettles because it undermines control. If they are watching, then first contact is not in our hands, but theirs. We cannot know their intentions, whether benevolent, indifferent, or hostile. The very thought destabilizes the narrative of human agents, reminding us that the universe may already be inhabited by observers who see us as curiosity, experiment, or perhaps stories to be told. And yet, awe accompanies fear. To be observed is also to be acknowledged, to be woven into a greater cosmic awareness. If we are specimens, we are at least specimens noticed. The paradox leaves us suspended between humility and wonder. Perhaps the search is not about finding others, but realizing they may have already found us. Time itself as a dimension. To us, time feels like motion. Moments slip from future into present, then into past, as though reality itself flows in a single, unstoppable direction. This intuition is so deeply woven into daily life that questioning it seems absurd. Yet physics has long suggested a radically different picture. Time may not flow at all. Instead, it may be part of a vast four-dimensional structure, what physicists call the block universe. In this model, past, present, and future all coexist, equally real, like pages in a book waiting to be read. The block universe emerges from Albert Einstein's theory of relativity. Before Einstein, Newtonian physics treated time as absolute, the same everywhere, ticking uniforms the cosmos. Relativity shattered that certainty. Einstein showed that time and space are not separate, but fused into a single fabric, space-time warped by mass and energy. Crucially, relativity revealed that simultaneity is relative. Two observers moving at different speeds may disagree about whether events happen at the same moment. If there is no universal now, then perhaps now itself is an illusion. This leads to the unsettling conclusion that all events, your birth, your present heartbeat, your eventual death, are equally real within space-time. Just as all locations in space exist, so do all locations in time. The universe is not a film reel playing frame by frame, but the entire reel at once. We experience the frames sequentially, but the film itself is complete. In Einstein's words, the distinction between past, present, and future is only a stubbornly persistent illusion. The implications are profound. In the block universe, death is not annihilation, but simply the end point of a world line, a trajectory through space-time. You do not vanish. Your life remains eternally inscribed within the cosmic fabric. Every moment you have lived still exists, as real as any other coordinate in space. In this sense, you are immortal, not because you continue into the future, but because your past remains forever. Yet the block universe also challenges our sense of freedom. If all moments already exist, then the future is not open, but fixed. Choice, agency, and possibility appear diminished. We feel as though we are carving paths through an unfolding reality, but the block suggests we are simply traversing a predetermined route. To many, This determinism feels suffocating, stripping life of spontaneity. Others, however, find comfort. If the future is already real, then uncertainty is only ignorant, not chaos. Philosophers have long wrestled this paradox. Presentism, the belief that only the present exists, aligns with intuition and everyday experience. Eternalism, the block universe, aligns with relativity and physics. The tension between them reflects a larger divide between subjective experience and objective description. We live as though time flows, yet the universe, at its deepest level, may be timeless. Some scientists attempt reconciliation by suggesting that the flow of time emerges from entropy. As disorder increases, we perceive direction, the arrow of time pointing from order to chaos. Others argue that the flow is psychological, a byproduct of how memory encodes the past, but not the future. Still others hint that consciousness itself may be entangled with time, creating the sensation of passage within a reality that is fundamentally static. The block universe leaves us in awe and unease. If true, it dissolves the fear of non-existence. Every moment of your life is eternally preserved, but it also dissolves the freedom of becoming, trapping existence in a frozen tableau. Between these poles lies the paradox of time, lived as flow, described as permanence, understood fully by neither. Time travel in physics. Few ideas capture the imagination of time travel. Stories of slipping into the past or leaping into the future fill our myths and our science fiction. Yet beyond fantasy, physics itself has flirted with the possibility that time may not be as rigid as it seems. Wormhole closed time-like curves and quantum theories of time all hint, however faintly, that the boundaries between then and now might be more porous than we assume. The most familiar proposal is the wormhole, a hypothetical tunnel connecting distant points in space-time. General relativity allows for such structures, sometimes called Einstein-Rosen bridges. If a wormhole could be stabilized an enormous if, it might serve as a shortcut not only through space but also through time. Move one mouth of the wormhole near a strong gravitational field or accelerate it close to light speed, and relativity predicts that time would pass differently for each end. Enter one mouth and emerge from the other, and you could, in theory, step into the past or the future. Closely related are closed time-like curves, solutions to Einstein's equations in which space-time bends back on itself, allowing a particle or perhaps a person to return to an earlier point in its own history. These mathematical constructs raise tantalizing possibilities, but also notorious paradox. If you could revisit the past, could you alter it? Could you prevent your own birth, creating the famous grandfather paradox? Physics entertain these scenarios on paper, but whether nature permits them in reality is another matter. Quantum mechanics complicates the story further. Some interpretations suggest that quantum systems can evolve in ways that mimic time loops where particles interact with past versions of themselves. Theoretical model post-selected quantum mechanics even propose that paradoxes might resolve automatically. If a contradiction would arise, that timeline simply has zero probability. In such views, the universe chooses consistency, ensuring that time travel never breaks causality. Others point to the many worlds interpretation, where traveling to the past might simply deposit you in a different branch of the multiverse, avoiding paradox entirely. Yet despite the elegance of these ideas, skepticism remains dominant. Wormholes, if they exist, would require exotic matter with negative energy to remain open, something never observed. Closed time-like curves may be mathematically valid, but could be prohibited by deeper laws of physics, a principle Stephen Hawking called chronology protection. Quantum time models remain speculative, with no experimental support. For most physicists, time travel remains a playground for thought experiments rather than a roadmap to engineering. Still, the persistence of these theories reveals something profound. Even when constrained by equations, the universe resists simple boundaries. Space and time, once thought absolute, prove elastic and surprising. The very fact that relativity permits time loops, however impractical, suggests that reality is stranger than intuition allows, and the quantum world, with its probabilistic rule, only deepens the mystery. For humanity, time travel represents more than physics. It embodies longing. We yearn to revisit lost moments, to correct mistakes, to leap ahead and glimpse the future. The paradoxes remind us that such control may be illusory, but the theory stories remind us that time itself is not as straightforward as it seems. The laws of physics leave the door cracked just wide enough to keep wonder alive, even if practicality slams it shut. Thus, time travel in physics remains balanced between possibility and skepticism. The mathematics allows it, the evidence withholds it. Between these poles lies a truth both humbling and inspiring. We live in a universe where the boundaries of time are not fully known, and as long as those boundaries remain uncertain, the dream of stepping beyond them endures. What lies beyond linear time for most of us? Time feels like a single thread, linear, unidirectional, and unavoidable. We move forward moment by moment, never able to pause, rewind, or leap ahead. But some theories in modern physics suggest that this thread may not be the whole picture. If additional dimensions exist beyond the familiar three of space and one of time, then time itself might be navigable, more like a landscape than a prison. What appears to us as linear could be only the narrowest slice of a much richer reality. In string theory and related frameworks, the universe may contain many hidden dimensions curled up beyond our perception. We move freely in space because we evolved within it. But what if time, too, is embedded in higher dimensional structures we cannot access? From this perspective, past, present, and future are not discrete events, but coordinates in a larger geometry. To beings capable of perceiving or moving through this geometry, time might not flow at all. It might be traversed like terrain. Imagine an entity able to step outside of linear time, regarding it as we regard a map. Our struggles with past and future would look to them like landmarks, fixed, simultaneous, observable at will. Where we see history unfolding, they might see it all at once: the birth of Earth, the rise of humanity, and even our distant extinction spread across a single, timeless vista. To such beings, the very concept of waiting would be alien. For them, all moments would be accessible, all possibilities navigable. The contrast with human limitation is stark. We are locked inside the arrow of time, forced to experience existence as sequence. Memory points backward, anticipation points forward, and we can inhabit only the thin edge we call the present. Even our most advanced technology does not allow us to break free. Clocks merely measure our captivity, but higher dimensional theories raise the haunting possibility that this limitation is not fundamental. It may be only a matter of perspective, one that more advanced civilizations could transcend. For us, the thought is both humbling and unsettling. If aliens have mastered higher dimensional time, then they could observe us as easily as we observe ants in a colony. To them, our entire history might already be visible, our futures already catalogued. They would not need to communicate across years or light year. They could step to the moment choose. Our search for signals may therefore miss the point. While we wait for contact, they may already know the outcome of our story. Skeptics, of course, caution that higher dimensional time is speculation piled upon speculation. String theory remain unproven, and our evidence for extra dimensions is indirect at best. Even if such dimensions exist, it is unclear that consciousness or any physical system could navigate. But the mere fact that physics allows for such possibilities reveals how limited our intuitions are. Time feels absolute because our biology evolved within it. That does not mean it is ultimate. The prospect invites both awe and dread. On one hand, it suggests that our universe may be far richer than we perceive, filled with possibilities beyond imagination. On the other, it raises uncomfortable questions about agency. If all moments are fixed and accessible, are we anything more than characters in a story already written? And if others can move through that story at will, what becomes of our freedom, our privacy, our sense of self? Perhaps we will never know. But by contemplating what lies beyond linear time, we expand the horizon of possibility. Whether such dimensions exist or not, the thought reshapes our understanding of what it means to live as temporal creatures in a cosmos that may not be bound to time's arrow. Civilizations beyond the Kardashev scale. When astronomers imagine civilizations beyond Earth, they do not only ask if such civilizations exist, but also how advanced they might be. In 1964, Soviet astrophysicist Nikolai Kardashev proposed a simple yet profound framework for thinking about technological growth on a cosmos cosmic scale. Known as the Kardashev scale, it measures civilizations by the amount of energy they can harness and control. The categories Type 1, Type 2, and Type 3 are less about specific technology than about thresholds of power, each one representing a leap into new cosmic domains. A Type I civilization controls all the energy available on its home planet. For Earth, that would mean harvesting every joule from sunlight, wind, tides, and geothermal sources, as well as managing all fossil and nuclear reserves with perfect efficiency. Such a society would no longer fear energy shortages. Its technological capacity would saturate the globe. By Kardashev's definition, humanity does not yet qualify. We are often called a Type 0 civilization, drawing only a fraction of Earth's potential. Estimates suggest we might reach Type 1 within a few centuries if we survive long enough. A Type 2 civilization takes a step far more audacious, harnessing the energy of its star. Imagine a Dyson sphere or Dyson swarm, a vast collection of structures, orbiting the sun to capture its output. The energy available at this stage is staggering, billions of times greater than planetary reserve. A Type 2 society could power interstellar travel, manipulate planetary climates at will, or even begin to engineer its star's life cycle. Such feats may sound like science fiction, but they remain consistent with physical law. The leap is not about possibility, but scale. A Type 3 civilization operates on the scale of an entire galaxy. By controlling energy from billions of stars, it ascends to a level almost incomprehensible to us. Such a society could move stars, shape galactic structures, or spread its influence across millions of light years. If Type 1 represents planetary mastery and Type 2 stellar mastery, then Type 3 is cosmic mastery. To us, their existence would appear godlike, yet the Kardashev scale treats it as a natural progression of energy use. Contrasting our current state with these possibilities is sobering. Humanity still struggles with sustainability, climate change, and global cooperation, yet the Kardashev framework suggests that these are only early hurdles on a much longer trajectory. We are fledgling compared to what may exist elsewhere, species that have already crossed thresholds we cannot yet fathom. If they are out there, their power would dwarf ours as much as our electricity dwarfs the flicker fire. The elegance of the Kardashev scale lies in its simplicity. By reducing technological progress to energy control, it avoids cultural bias. It does not matter what languages, customs, or histories a civilization has, only how much power it commands. This makes the scale useful not only as speculation, but as a guide for CT. Detecting waste heat, stellar engineering, or unusual galactic signatures could reveal civilizations higher on the scale, even if they never send us messages. Yet the scale also provokes unease. If advanced civilizations are common, why do we not see evidence of Dyson spheres or galactic engineering? This is part of the Fermi paradox, the haunting silence amid cosmic possibility. Perhaps the leap from Type 0 to Type 1 is far rarer than Kardashev imagined, or perhaps higher civilizations exist but conceal themselves or operate in ways beyond our recognition. For now, the Kardashev scale remains both a roadmap and a mirror. It shows us how far we may climb, while reminding us of how small we remain. Humanity hovers on the threshold of planetary maturity, peering upward at a ladder that stretches toward the star. The control of time. The Kardashev scale imagines civilizations climbing by harnessing greater and greater amounts of energy. Yet energy is not the only frontier. For creatures bound by linear time, there may be an even more radical axis of advancement, the mastery of chronology itself. If energy defines power over matter, then time may define power over existence. What would a civilization look like if it advanced not only along the Kardashev ladder, but also along a new, speculative, temporal? At the first level of such a scale, a species might achieve basic manipulation of temporal perception. Humans already experiment with technologies that stretch our subjective experience of time, neurochemistry, altering awareness, relativity, allowing travelers moving near light speed to experience slower clock. These are primitive beginnings, glimpses of how time might be bent at the edge. A higher level would involve practical control of time dilation. Civilizations at this stage could exploit relativistic effects deliberately, slowing time for long journeys, preserving themselves while centuries passed outside, or accelerating their perception to act with superhuman speed. While still consistent with known physics, such mastery would grant an advantage akin to stepping outside history's flow, choosing when and how to engage with unfolding events. Beyond this, a civilization might reach the threshold of temporal engineering. Just as Type 2 on the Kardashev scale captures a star's energy, a temporal Type 2 might manipulate closed time-like curve or stabilize wormholes. Such beings could navigate backward as well as forward, accessing epochs as though they were destinations. To them, history would not be fixed memory, but traversable landscape. They might study their own beginnings firsthand or intervene in subtle ways that ripple across centuries. At the farthest reaches lies the almost unimaginable, a civilization for whom time is no longer linear at all. A temporal Type 3 might perceive the whole of history simultaneously, every past and future coexisting in a timeless awareness. For such entities, causality would be a tool, not a boundary. They could sculpt not just matter and energy, but the very chronology of the cosmos. To us, their presence would resemble divinity, omniscience, born not of faith, but of physics pushed to its furthest horizon. Contrasting energy mastery with temporal mastery highlights an important distinction. The Kardashev scale assumes progress outward, expanding reach across planets, stars, and galaxies. The temporal scale imagines progress inward, collapsing the distance between moments, bending the one dimension we all experience but cannot escape. Where energy mastery conquers space, temporal mastery conquers fate. The idea is speculative, yet it forces us to reframe what advanced might mean. We assume alien civilizations would appear powerful because of their technologies, vast structures, interstellar ships, galactic engineering. But what if their true mastery is invisible, woven into time itself? They may not build Dyson spheres because they do not need to. Their domain would not be stars, but centuries. Their tools would not reshape galaxies, but chronology itself. For humanity, trapped in the flow of linear time, this speculation is humbling. We count progress in centuries and energy in what, but these measures may capture only one axis of possibility. If civilizations exist who stride across time as easily as space, then our notion of advancement is provincial, a child's sketch of a far greater architect. The temporal scale remains conjecture, but its value lies in expanding imagination. It reminds us that mastery of matter may not be the highest form of intelligence. Perhaps the ultimate horizon of civilization is not controlling energy, but mastering the very fabric of time. Future watchers hypothesis. When we imagine extraterrestrial, we usually place them far away in another star system, another galaxy, perhaps another universe. But what if the most advanced civilizations are not separated from us by distance, but by time? The future watchers hypothesis proposes that the others we seek may not be across the cosmos, but ahead of us in our own timeline. They would not be neighbors scattered light years away, but descendants or successors, civilizations that emerged from Earth or perhaps from nearby worlds millions of years in the future. This idea reframes the silence of the cosmos. If civilizations survive long enough, their mastery of energy and time may make space travel trivial. A galactic society could emerge within tens of millions of years, leaving traces we would expect to see: Dyson spheres, engineered galaxies, or signals blazing across the star. Yet we observe none of these. One explanation is sober. Such civilizations rarely survive. Another is more provocative. They do not appear because they are not in our present. They exist in futures we cannot yet reach, futures where their vantage allows them to look backward into our time. The concept draws power from relativity itself. For beings capable of moving near light speed, time dilates. Centuries for us might be decades for them. For those who manipulate wormholes or higher dimensions, time may not be a barrier at all. If so, the aliens we imagine could be temporal neighbors, able to peer into our era just as easily as we peer into the night sky. Our search for radio signals or megastructures might miss them entirely because their method of contact is not communication across distance, but observation across chronology. This perspective also casts our technological trajectory in a new light. If humanity avoids self-destruction, what might we become in a million years? We already manipulate genes, simulate world, and bend time with relativity in our spacecraft and satellite. Extrapolate those trends and future humans or post-human might look indistinguishable from the aliens we expect. The Future Watch hypothesis blurs the line. Perhaps they are not strangers at all, but what we ourselves may evolve into. But an unsettling part is the asymmetry. If they exist, they may already know us while we cannot know them. They could observe history as a timeline, seeing our civilizations rise and fall like waves on a shore. To them, our present might be archived, studied, or even influenced in ways we cannot perceive. We wonder if anyone is out there, while the answer might be that someone is already here, just not now. Skeptics dismiss this as speculative layering of science fiction on physics. There is no evidence of time-peering civilization, and the challenges of manipulating chronology may prove insurmountable. Yet the hypothesis highlights an often overlooked truth. Time is as vast a frontier as space. When we search for others, we assume synchronicity that if civilizations exist, they exist now. But why should cosmic intelligence align with our brief epoch? The universe has been alive with possibility for billions of years and may remain so for billions more. To assume we share the same moment may be the greatest anthropocentric error of all. The Future Watchers hypothesis may never be testable, but it reframes our imagination. It reminds us that alienness is not only a matter of distance, but of perspective. The watchers we seek may not be across the stars, they may be waiting in our own future, gazing backward at us as we gaze forward at them. Signals from the future. When we imagine contact, advanced civilization, we usually picture spaceships, radio signals, giant engineering projects visible across the stars. In other words, communication depends on travel, whether of matter, of light. But what if information could move without crossing space at all? What if the most advanced beings don't reach us through vast journeys, but by sending data backward in time? Such a possibility may sound like science fiction, yet physics has toyed with mechanisms, quantum entanglement, retrocausality, and exotic interpretations of time that make information without travel a provocative frontier. Quantum entanglement is the most famous candidate. When two particles are entangled, a change in one instantly correlates with the other, no matter how far apart they are. Einstein derisively called it spooky action at a distance because it appeared to defy relativity's ban on faster-than-light communication. In practice, entanglement cannot transmit usable messages faster than light, but the correlations it reveals challenge our understanding of cause and effect. Some theorists speculate that entanglement might be reinterpreted as information shared not across distance but across time. Instead of violating relativity, perhaps entangled particles reflect a deeper temporal connection, one that an advanced civilization might exploit. This leads to the idea of retrocausality, the notion that effects can influence causes, that information might flow backward as well as forward. In certain quantum models, outcomes in the future appear to determine probabilities in the past. Though controversial, these interpretations raise the possibility that the arrow of causation is not as rigid. If retrocausality is real, then communication across time might be possible not through machines roaring across galaxies, but through subtle manipulations of quantum state. Contrast this with conventional SETI. Traditional searches rely on detecting electromagnetic signals, radio transmissions, laser pulse, or other deliberate beacon. But these signals are constrained by distance and speed. A message sent from even the nearest star takes years to arrive. A message from across the galaxy would take tens of thousands of years, making dialogue nearly impossible. Temporal SETI, by contrast, sidesteps distance entirely. If advanced civilizations can send information backward, then contact could happen instantly, regardless of how far away they are in space. The bottleneck is not distance, but capability. The implications are staggering. Imagine receiving a message not from across
stars, but from the
It might contain warnings, guidance, or even glimpses of technologies yet to be discovered. Such communication would transform not only our search for extraterrestrials, but also our understanding of history itself. Were some ancient myth or prophecies faint echoes of temporal contact messages misinterpreted through cultural lenses? If so, our ancestors may have already encountered the phenomenon without the tools to recognize it. Skeptics remind us that physics jealously guards causality. Time travel of information risks paradoxes, the classic grandfather paradox of influencing the past in ways that prevent the present. Yet some models suggest that paradoxes may be self-correcting, that retrocausal effects are constrained to maintain consistent. If so, advanced civilizations might exploit these loopholes, embedding data in the fabric of quantum reality without unraveling causality. To us, it might appear as noise, coincidences, or anomalies until we learn how to decode it. Whether or not temporal communication is possible, considering it broadens SETI's horizon. Instead of only listening for radio waves, we might search for patterns in quantum experiment, anomalies in data, or signals that appear to know outcomes before they occur. Temporal SETI invites us to expand our imagination. Aliens may not shout across space but whisper across time. And if they can, then perhaps they already have. Archaeology of the future. Archaeology traditionally looks backward. We sift through ruins, bones, and pottery shards to reconstruct the lives of those who came before us. The ground beneath our feet is a time capsule, each layer preserving fragments of vanished world. But what if traces of civilization could arrive not only from the past, but also from the future? Could we, in principle, uncover artifacts not of ancient ancestors, but of beings who have not yet existed? This strange inversion in archaeology of the future emerges naturally from theories of retrocausality and temporal manipulation. The idea may sound paradoxical. How can the future leave evidence in the present? Yet physics does not entirely forbid it. If information can, under certain conditions, move backward in time, then intentional messages or even material structures could be seeded into history. Just as fossils preserve evolutionary history, perhaps anomalies in our present reality could serve as fossils of the future, artifacts planted by civilizations with mastery over time. Imagine discovering an object of impossible precision in geological strata technology predating the species capable of building it. While most such claims fall into pseudoscience, the concept highlights a provocative possibility. What if some anomalies are not mistakes in dating or hoaxes, but deliberate implant? An advanced civilization seeking to influence or communicate with its ancestors might choose to leave breadcrumbs in eras where they could later be found. Instead of waiting for us to develop interstellar communication, they might ensure that when our tools of discovery matured, their message would already be waiting. In this sense, archaeology could expand beyond the study of the past into the search for temporal artifacts. Just as we scrutinize fossils for signs of ancient biology, we might one day examine data, quantum noise, or geological record for traces that do not belong. Our tools may need to be reimagined: particle accelerators, dig site, quantum experiments as excavation pit, physics itself as the spade. The field might no longer ask only what did our ancestors leave behind, but also what might our descendant or others beyond us have placed here for us to find. This inversion also reframes CT. Conventional searches look outward for radio waves or megastructures. Temporal CT considers whether signals could come from the future. Archaeology of the future extends that thought. Instead of waiting for transmissions, perhaps we should search for anomaly already embedded in our world. A message could be hidden in the digits of physical constant, the patterns of cosmic radiation, or in the genetic code itself, places resilient enough to survive across deep time, yet discoverable once intelligence reaches the proper state. Beyond concept carries unsettling implication. If the future can leave traces in the present, then our timeline may not be as open as we believe. We might already be influenced, nudged by subtle artifacts that shape our path. The myth of free will collides with the possibility of design seeded backward. On the other hand, such artifacts might represent guidance rather than control, a way of ensuring survival, like a parent leaving instructions for a child not yet born. Skeptics argue that extraordinary claims require extraordinary evidence, and so far, no undeniable artifact of the future has been found. Most anomalies collapse under scrutiny, explained by natural processes or human error. But the absence of evidence is not evidence of absence. Archaeology of the future is not a claim that such artifacts exist, but an invitation to broaden our imagination. If time is malleable, then the future, like the past, might leave its footprint. Perhaps one day we will stumble upon a message not from the distant stars, but from tomorrow. Prophets, myths, and temporal echo. Throughout history, humanity has been visited by visions prophets who claim to see the future, myths of gods who descended from the sky, stories of fate written long before it unfolded. Traditionally, these accounts are treated as religion, folklore, or cultural imagination. Yet when examined through the lens of temporal speculation, another possibility emerges. Could some of these narratives be temporal echo, distorted encounters with beings or influences outside the ordinary flow of time? Consider the figure of the prophet. In many traditions, prophets are not inventors of new truths, but receivers of revelation. They glimpse what has not yet occurred, often with uncanny specificity. Skeptics explain this through psychology, coincidence, or retrospective editing tech. But what if certain insights arose from interactions with information seeded back? Culture without science, the experience might appear divine. To us, it might hint at a kind of temporal transmission data leaking across chronology, misunderstood as sacred vision. Myths, too, carry peculiar echoes. The Greek moirai, or fates, wove destinies on their cosmic loom, suggesting that human lives were predetermined. Norse mythology imagined Ragnarok, a detailed prophecy of the world's destruction. In Hindu cosmology, vast cycles of time were mapped with eerie precision, epochs lasting billions of years, strangely close to modern cosmological estimate. Are these coincidences of imagination, or do they suggest that ancient minds brushed against truths outside their age? If advanced civilizations could view time as a landscape, perhaps fragments of their knowledge slipped into human storytelling. Even modern accounts resonate with this possibility. Reports of visions, precognition, or encounters with others often describe beings unconstrained by time entities who appear suddenly, deliver cryptic warnings, and vanish. While psychology offers explanations in dreams, hallucination, or stress, the persistence of such themes across cultures suggests a deeper archetype. They reflect humanity's intuition that time is not sealed, that whispers of the future may occasionally drift into the present. Speculative science lends fragile scaffolding to these intuitions. Retrocausality in quantum mechanics, closed time-like curves in relativity, and higher dimensional theories all hint causation may not be strict one way. If so, the boundary between future and present is more permeable than we think. Instead, such a world, myths of prophecy could be reinterpretations of genuine, if misunderstood, encounters with temporally advanced intelligences or with echoes of our own descendants reaching backward. The danger, of course, is conflating myth with science uncritically. Most legends reflect cultural needs rather than physical truth. Prophecy often succeed only through vagueness, and myths thrive on metaphor. To treat every ancient story as proof of alien or temporal contact risks distorting history and dismissing the creativity of human imagination. Yet, to dismiss them entirely risks overlooking kernels of insight preserved in symbolic form. Myths may not be literal records, but they can serve as cultural fossils, preserving fragments of encounters refracted through belief. This contrast between superstition and speculative science invites humility. We cannot verify that prophets glimpsed the future through temporal echo, nor that myths encode real encounters with beings outside time, but the persistence of such stories across eras suggests they tap into a deep intuition. That reality is not as linear as it appeared. Where ancient cultures used gods and destiny to explain these intuitions, modern physics offers equations and paradox. Both are attempts to grapple with the same mystery, the strange elasticity of time. In the end, prophets, myths, and temporal echo remind us that the boundary between imagination and reality is porous. Perhaps myths are only stories. Perhaps they are distorted memories of genuine encounters. Either way, they testify to humanity's enduring sense that we live within a universe richer than our moment-to-moment perception allows. The ethics of being watched. For most of human history, Earth has felt like a sanctuary. The sky was vast, but it was also distant, a backdrop for myth rather than a stage for surveillance. Even when we imagined gods watching us, Their gaze was symbolic moral, not literal. But as the possibility of advanced civilizations enters the conversation, a darker thought: what if we are being observed right now? What if Earth, our home, is less a private dwelling than a cosmic laboratory? The dread of surveillance is deep human. Privacy defines individuality. It is the ability to exist without constant scrutiny. On Earth, losing privacy feels like losing freedom. We react with unease when cameras monitor our street or corporations track our data. Expand that unease to the scale of the cosmos, and the fear sharpens. Perhaps we are not only observed by governments or companies, but by beings far beyond us. Civilizations so advanced we cannot even detect their instrument. The observer's paradox, already considered in temporal speculation, cuts to the heart of this anxiety. We scan the skies expecting silence or signals, but rarely do we ask what it feels like if the roles are reversed. If they watch, their technologies might be subtle, embedded not in visible spacecraft, but in the very fabric of reality, quantum anomalies, gravitational whispers, or disturbances too faint for us to pass. To them, our history may already be an open book. This possibility reframes the meaning of Earth. To us, it is a private home, the cradle of humanity. To others, it might be a case study, a planet entering technological adolescence, struggling with survival, watched carefully as an experiment in cosmic evolution. Perhaps they are patient gardeners, waiting to see if we flourish or collapse. Perhaps they are indifferent archivists, recording outcomes without interference. Or perhaps, more unsettling still, they are curious voyeurs, regarding us with interest, but not concern. The contrast between private home and laboratory is profound. A home implies ownership, intimacy, and safety. A laboratory implies exposure, vulnerability, and experiment. If Earth is only private in our perception, while in reality transparent to higher intelligences, then our sense of autonomy may be illusory. We would be less like sovereign beings and more like specimens living, striving, fearing, all under the gaze of watchers we cannot perceive. Yet privacy at the cosmic scale may be impossible by definition. Earth glows with biosignatures, oxygen-rich atmosphere, radio leakage, city lights glittering against the dark. Any advanced astronomer within 100 light years could already know we exist. In this sense, our privacy ended decades ago when we began broadcasting to the stars. Our desire for secrecy may be futile in a universe that rewards visibility. Still, the emotional weight remains. To be observed is to lose innocence. If we are watched, then our wars, mistakes, and triumphs are not just ours, they are performances, witnessed by unknown eyes. That realization unsettles because it strips us of control. We can choose to broadcast, but we cannot choose to remain unseen. And yet alongside the dread lies wonder. To be observed is also to be acknowledged, to matter, in a cosmos that otherwise seems indifferent. If Earth is a laboratory, then we are at least subjects of interest, woven into a larger tapestry of curiosity. The fear of exposure coexists with the awe of significant. Cosmic privacy may be an illusion, but perhaps the greater question is not whether we are observed, but how we choose to live knowing we might be. Do we shrink under the gaze, or do we rise, aware that our story may already be part of someone else's archive? Free will under observation. If we are being observed by advanced civilization, what does that mean for human freedom? Autonomy is central to our sense of self, the belief that we choose our path, shape our destinies, and act authentically. Yet observation changes behavior. Psychologists have shown that people act differently when they believe they are being watched, more cautious, more performative, more constrained. If surveillance extends not just from governments or society, but from beings beyond Earth, then the very foundations of free will may feel compromised. On a personal scale, observation alters action in subtle ways. Cameras in public spaces reduce crime, but also reduce spontaneity. Social media thrives on self-presentation, transforming everyday lives into curated performances. The panopticon, a metaphor introduced by philosopher Jeremy Bentham and later expanded by Michel Foucault, describes the ultimate surveillance state. Individuals modify behavior because they might be watched, even if no one is looking. This creates internalized control where freedom freedom becomes illusion. Extend this idea to the cosmos and the implications deepen. If humanity believes it is observed by higher intelligences, we may unconsciously reshape our choices, not only as individuals, but as a species. The question is whether this undermines free will or merely reframes it. If watchers exist but do not intervene, then our decisions remain our own, even if tinted by self-consciousness. But if observation influences us through subtle cues, implanted artifacts, or temporal nudges, then autonomy becomes porous. We act, but not entirely freely. Our agency is intertwined with unseen oversight. This tension mirrors debates in philosophy. Existentialists like Sartre argued that humans are condemned to be free, carrying the burden of choice even in oppressive systems. Observation does not erase freedom, it magnifies responsibility. To act authentically is to resist shaping oneself merely for the gaze of others. But the Stoics took a different view. Freedom lies not in external conditions, but in inner discipline. Even if the cosmos itself watches, our control lies in how we respond. From either perspective, the observer does not eliminate autonomy, it challenges it. Yet there is also a more unsettling possibility. Advanced civilizations, especially those with mastery over time, may not simply observe but anticipate our choices. If they can see the timeline of humanity in its entirety, then free will may be an illusion. Our actions would already be part of a recorded script, our decision pre-written. From this vantage, being observed collapses into being determined, leaving us as actors unaware of the play we perform. Still, physics and philosophy leave room for ambiguity. Quantum mechanics introduces indeterminacy. Outcomes are not fully predictable until they occur. Consciousness itself, poorly understood, resists reduction to simple determinism. Perhaps even advanced watchers cannot know every detail of our future, only probabilities. If so, free will may not vanish under observation, it may coexist with it, shaped by the strange interplay of choice, chance, and scrutiny. For humanity, the psychological impact may be more important than the metaphysical truth. Believing we are watched could inspire fear, conformity, or paralysis, but it could also inspire responsibility, as though our actions matter not only to ourselves but to the cosmos. In this sense, the gaze of hypothetical watchers becomes a mirror, reflecting our own struggle to live authentically in the face of uncertainty. Whether or not cosmic observers exist, the idea forces us to ask, do we act for ourselves or for the eyes we imagine upon us? Free will under observation becomes not just a metaphysical problem but an existential test, one that challenges us to define what it means to be human when the universe itself might be watching. Are we an experiment? The thought that we might be observed is unsettling enough, but an even deeper unease follows. What if we are not simply watched but design? What if our existence is less the unfolding of independent history and more the unfolding of a project, an experiment conducted by others? This possibility echoes through both philosophy and science fiction, raising questions about meaning, purpose, and autonomy. The idea of being part of an experiment is not new. Ancient religions sometimes framed humanity as the creation of gods who tested their followers through trials of faith, suffering, or obedience. The Book of Job portrays life as a cosmic wager. Myths across cultures imagine humans as clay-shaped by higher power, their lives subject to divine curiosity. While such tales speak in spiritual language, they share the unsettling theme that existence is not primarily for us, but for others. Modern speculation reframes this theme through the lens of technology. The simulation hypothesis suggests that advanced civilizations could create digital universes populated with conscious being. If such simulations are feasible, then the odds may favor us being inside one. In that case, our world is not real in the ultimate sense, but the controlled environment of an experiment. Every law of physics, every particle, every choice might be part of a coded framework designed for study, entertainment, or purposes we cannot fathom. The implications are profound. If we exist for ourselves, then our struggles and triumphs carry intrinsic meaning. But if we exist as an experiment, meaning may lie outside us in the goals of the experimenter. Are we a test of morality, resilience, or creativity? Are we entertainment for entities far beyond us, like characters in a cosmic play? Or are we data points in an infinite catalogue of possible civilization? To imagine ourselves as an experiment is to imagine our agency reduced, our autonomy contextualized within a larger framework. Skeptics counter that such ideas are unfalsifiable, blurring into metaphysics. We cannot prove we are in a simulation, nor disprove it. And even if true, it may not matter. The reality we experience is real enough for us. Pain, love, joy, and loss are not illusions, simply because they might be embedded in another system. From this angle, the hypothesis changes nothing about how we live, even if it unsettles our sense of ultimate origin. Still, the experiment hypothesis resonates because it captures the asymmetry we fear, that we are subjects, not agents, observed but not controlled. It also provides a lens for interpreting silence in the cosmos. If we are part of a controlled study, perhaps contact with others is deliberately withheld. The great silence of SETI might not reflect absence, but design, the constraint of an experiment where we are meant to evolve without interference. Yet even within this framework, meaning is not lost. If existence is an experiment, then how we respond to it is ours. A lab rat cannot choose its condition, but it can act within them. Likewise, even if humanity is observed or simulated, the choices we make toward each other remain authentic. Ethic, creativity, and love are not diminished by the possibility of being watched. They are amplified. So the question lingers, are we living for ourselves or for others? Perhaps the answer does not matter. To live as though we are free, to create meaning in a world that might be a project, is itself an act of defiance and perhaps the truest form of freedom. Skeptics and alternatives, speculation about communication across time is exhilarating, but sooner or later it collides with the sobering guardrail physics. For all the wonder of wormholes, retrocausality, and quantum entanglement, most scientists remain cautious, if not outright dismissive, of the idea that information can travel backward in time. Their skepticism rests on a simple but powerful principle. Physics is a discipline bound to evidence. So far, no experiment has ever demonstrated time-reversing communication. The first objection is causality. Modern science is built on the assumption that causes precede effect. If this order collapses, paradoxes abound. A message sent into the past could alter conditions that made the message possible in the first place, the classic grandfather paradox. To preserve logical consistency, many physicists argue the universe must forbid such violations. Stephen Hawking famously proposed a chronology protection conjecture, suggesting that the laws of physics prevent time loops and retroactive signaling. While elegant models of closed, time-like curves exist on paper, reality may enforce stricter rule. Another barrier lies in quantum mechanics. Entanglement is often misinterpreted as allowing faster-than-light communication, or even retroactive influence. In truth, entanglement transmits correlation, not information. When one particle is measured, its twin is instantly determined, but the outcome is fundamentally random. No usable message can be extracted without classical communication, which remains constrained by light speed. For this reason, mainstream physicists dismiss claims of quantum telegraph or time-bending signal as misunderstandings of the theory. Thermodynamics adds another layer of resistance. The arrow of time, our perception of flow from past to future, is deeply tied to entropy, the natural tendency toward disorder. Reversing information flow would imply reversing entropy locally, which seems to violate one of the most robust principles in physics. While microscopic reversals are possible in isolated systems, scaling this into macroscopic, deliberate communication appears implausible. Empirical limits also guide skepticism. Despite decades of searching, no experiment has produced evidence of signals from the future. High-precision particle accelerators, astronomical observations, and quantum experiments show no signs of retroactive interference. If advanced civilizations were regularly sending information backward, some anomaly might be expected in our data, yet none has been confirmed. For scientists, absence of evidence strengthens the case that backward communication is unlikely, at least under the laws we currently. And yet, speculation persists. Why? Because the boundaries of physics have shifted before. Ideas once dismissed as absurd atoms, relativity, black holes eventually gained empirical support. The danger is not in skepticism, but in dogmatism. While most scientists reject retrocausal communication today, a minority argue that new physics could reopen the question. Certain interpretations of quantum mechanics, like the two-state vector formalism, allow for influences traveling both forward and backward in time. These remain free fringe views, but they remind us that physics is not a finished book. Still, the prevailing stance is caution. Science distinguishes itself from philosophy and myth by grounding claims in testable prediction. Without falsifiable experiments, backward communication remains speculation, not science. The burden of proof lies with those who propose it, and, so far, the evidence has not arrived. This does not mean the idea is worthless. It stimulates imagination, expands SETI's horizons, and challenges us to think differently about time. But it also highlights the crucial balance between speculative hope and empirical rigor, between what might be possible and what has been proven. At present, the limits of physics keep us tethered. Perhaps one day, those limits will bend. For pizza, now they remind us that awe must coexist with humility, and that wonder does not excuse us from the discipline of evidence. Misinterpreting the unknown. When faced with the unknown, humans have a long history of filling gaps with stories. Strange lights in the sky, mysterious sounds, or unexplained anomalies often ignite speculation about hidden intelligences. Yet, again and again, many of these wonders turn out to be natural phenomena. This tendency to misinterpret the unknown complicates our search for evidence of advanced civilizations or future watchers. Distinguishing genuine signals from mistaken impression may be one of the hardest tasks science faces. Consider the UFO phenomenon. For decades, people have reported encounters with flying objects that seem to defy explanation. Some accounts are sincere, others embellished, but nearly all thrive in ambiguity. Investigations have revealed that many UFO sightings are attributable to atmospheric phenomena, military aircraft, satellite, or even reflection. What feels like alien technology is often nothing more than a misidentified product of human technology or nature's complexity. The mystery arises not from the phenomenon itself, but from the limits of perception and context. Astronomy provides further example. The discovery of pulsars in 1967 was at first considered so bizarre that the signal was nicknamed LGM-1, Little Green Men. The precise, regular pulses seemed too orderly to be natural. Only later did scientists realize they were the signatures of rapidly rotating neutron stars. What was first suspected as intelligent communication turned out to be the rhythm of collapsed sun. The lesson is humbling. Nature often produces patterns that mimic design, reminding us that intelligence is not the default explanation. The same caution applies to fast radio bursts, FRBs, sudden and powerful emissions from deep space. When first detected, some researchers wondered if they might be artificial. Today, most are explained by astrophysical processes such as magnetar, yet the temptation persists to read anomalies as messages. This temptation grows sharper when framed by the idea of temporal watchers. If we already imagine civilizations peering at us through time, then any unexplained pattern risks being misread as proof of their presence. Skeptics emphasize that the human mind is predisposed to pattern recognition. We evolved to detect signal in noise because seeing connections even when false was safer than missing real threat. This tendency, called apophenia, explains why random data often feels meaningful and why myths or conspiracies flourish around anomaly. Future watchers, if they exist, would be difficult to distinguish from our own projection. Without rigorous standards of evidence, we risk mistaking our imagination for contact. At the same time, dismissing anomalies too quickly risks blindness. History shows that genuine discovery often masquerade as mistake. The cosmic microwave background was first detected as unexplained static. Plate tectonics began as a ridiculed hypothesis. If we assume every anomaly is natural, we may miss signals hidden in plain sight. The challenge is balance, maintaining skepticism without closing the door to possibility. This is why SETI emphasizes rigorous methodology. Candidate signals undergo layers of testing. Can they be explained by satellite, equipment error, or terrestrial interference? Only after exhausting natural explanations can an anomaly be considered a potential sign of intelligence. The same principle should apply to temporal speculation. If advanced beings leave traces, their signals must be robust enough to survive scrutiny. Otherwise, we risk building castles of meaning on foundations of coincidence. The fear and fascination of misinterpretation lies in what it reveals about us. In our longing not to be alone, we project watchers into every mystery, yet in doing so, we may blind ourselves to the subtler possibility that genuine observation, if it exists, would not resemble fireworks in the sky but patterns buried deep in reality itself. Why we want to believe. Behind every theory of extraterrestrial future watchers or temporal civilizations lies a more intimate question. Why do we want to believe at all? The search for others in the cosmos is not only scientific, it is deeply psychological and cultural. Our yearning for cosmic companionship reveals as much about humanity as it does about the universe. At the core is loneliness. Earth orbits in vast isolation, fragile world suspended in emptiness. The thought that we might be alone in the cosmos feels unbearable to many. Belief in others, whether aliens, gods, or temporal watchers, soothes that isolation. It promises that the universe is not indifferent, that someone is aware of. In this sense, the desire to believe is not just curiosity, it is comfort. Culture amplifies this longing. Ancient myths filled the heavens with gods and spirit, ensuring that the sky was never empty. Modern science fiction continues the tradition, populating galaxies with civilization, fleet, and empire. From Star Trek to Interstellar, our stories reflect a persistent hope that we are part of something larger, that humanity's struggles are shared on a cosmic stage. Even when depictions are terrifying, the underlying message is the same. The universe is alive with company. Psychology explains why this belief is compelling. Humans are pattern seekers, tuned to interpret ambiguous signals as meaningful. A rustle in the grass might be wind, but our ancestors survived by assuming it was a predator. This bias toward agency persists. A strange light in the sky, an unexplained noise in data, a sudden intuition, all easily transform into evidence of someone out there. The brain prefers connection to randomness. In cosmic terms, that means preferring watchers to emptiness, yet science demands restraint. The history of astronomy is littered with false alarm, canals on Mars, little green men pulsar, fast radio bursts, first mistaken for messaging. Each case reminds us that longing can cloud judgment. The discipline of science exists to challenge bias, to insist on evidence even when it disappoints. Doubt is not cynicism, it is protection against our tendency to see what we want to see. Still, yearning and skepticism coexist. Even the most cautious scientists often admit to quiet hope. Carl Sagan famously said that the universe is a pretty big place if it's just us. It seems like an awful waste of space. Hope does not disappear under doubt. It persists in the gaps, waiting for confirmation. The search for extraterrestrial intelligence is fueled as much by wonder as by method. The tension between belief and doubt defines the human condition. On one side lies the comfort of companionship, the dream of cosmic community. On the other lies the cold silence of observation, the possibility that the universe is vast and empty, or that we are watched but never answered. Both possibilities are unsettled, but both drive us forward. Belief pushes us to search. Doubt ensures we search carefully. Ultimately, the desire to believe says something profound about us. It reflects our refusal to accept insignificance. Whether through myths, religions, or scientific projects, we insist that our lives connect to a larger story. Even if the watchers never reveal themselves, the very act of looking outward binds us together, fueling culture, imagination, and discovery. We want to believe because belief bridges the gap between solitude and meaning. Science tempers that belief with discipline, reminding us that truth must withstand scrutiny. Yet the yearning remains, undiminished by silence, a testament to our place as seekers in a universe that may or may not answer back. Time, consciousness, and alien minds. Human beings experience time as a flow. Past, present, and future appear to unfold in sequence, like frames in a film reel, each one passing irreversibly into memory. This perception is not merely cultural, it is built into the architecture of the brain. Neuroscience shows that our cognition depends on temporal order. Memory encodes the past, awareness processes the present, and anticipation projects into the future. Without this linear scaffolding, consciousness as we know it could not function. Our brains construct continuity by stitching together discrete neural events into the sensation of smooth passage. The brain's prefrontal cortex integrates signals across fractions of a second, creating the illusion of a now that feels continuous. Psychological experiments reveal how fragile this construction is. Delays in sensory input can be misaligned, causing distortions in perceived timing. Yet despite these quirks, the overarching pattern is clear. Human consciousness depends on linearity. To us, existence without before and after would be incomprehensible. But what if other forms of mind are not bound by this constraint? The possibility of alien or post-human intelligence invites speculation about post-temporal consciousness mind that perceive time not as sequence but as totality. Imagine beings for whom the entire timeline is accessible at once, every moment equally present. To them, linear perception might seem like a primitive filter, a narrow bottleneck through which reality is experienced one drop at a time. The contrast is striking. Where we see history as unfolding, they might see it as complete. Our memories and predictions, limited by uncertainty, would appear to them as unnecessary. Why remember, anticipate, if all moments coexist? Communication with such entities would be daunting. How do you converse with a mind that already perceives your questions and your answers simultaneously? To them, dialogue may be redundant, as every exchange is already part of their awareness. This thought challenges our assumptions about intelligence. We often imagine advanced civilizations as versions of ourselves with bigger tools, faster ship, larger compute. But if consciousness itself evolved, then their mental world, ours, post-temporal mind would not think ahead because it would need. Instead, it might explore patterns across time, experiencing existence as structure rather than process. Hints of this difference appear even within human experience. Mystical traditions across cultures describe altered state in which time seems to dissolve, moments of timeless unity, visions where past and future blur. Neurological studies of meditation and psychedelics reveal that disrupting the brain's temporal process can generate such sensation. While fleeting for us, these glimpses suggest that consciousness may not be inherently linear, but constrained by our biology. If evolution or technology removed those constraints, other modes of time perception might emerge. The implications for alien contact are profound. If advanced civilizations experience time differently, then their motivations, behaviors, and communications would appear alien, not just in form, but in temporality. They might not wait for us because waiting presumes linear passage. They might not plan because planning presumes uncertainty. Instead, their engagement with reality could resemble design orchestration, arranging events across epochs with the same ease we arrange objects in space. For us, trapped in linear flow, the very idea is destabilizing. We cherish free will, anticipation, and memory as the anchors of identity. A post-temporal mind might regard these as illusions, useful fictions within a limited frame. To encounter such a being would not only challenge our science, it would challenge our sense of self. In the end, our linear perception defines us, but it may not define consciousness. The possibility of post-temporal minds at our experience of time is not the unit truth, only a window shaped. Beyond that window may exist ways of being as incomprehensible to us as color is to the blind, alien mind as timeless entity. When humans imagine extraterrestrial intelligence, we almost always begin with ourselves. We picture aliens as advanced versions of human beings, smarter, stronger, longer lived, perhaps more cooperative or more ruthless. Yet what if the true difference is not physical, technological, but cognitive? What if advanced alien minds do not experience time the way we do at all? Instead of moving through before and after, they might inhabit a state of eternal present, existing outside the linear narrative that defines human thought. Human consciousness is inseparable from sequence. We remember the past, act in the present, and anticipate the future. Our very identities are story, a chain of events linked by cause and effect, bound by time's arrow. Remove sequence, the self seems to unravel. Narrative is our foundation. But to imagine beings who do not think in narratives is to imagine minds shaped by a different architecture of reality. Such entities might not recall or predict. They might perceive all events simultaneously, experiencing existence as a totality rather than as unfolding. To them, your childhood, this moment of reading, and your eventual death would be equally present, equally accessible. Their awareness would not travel from one point to another, but would embrace the whole at once. Communication with such beings would be baffling. Our questions would seem nonsensical. What will happen next assumes a future that does not exist for them. They might respond not with answers, but with pattern, offering us glimpses of connections across time that we struggle to parse. This timeless mode of being resonates with certain mystical traditions. tradition. In Buddhist and Hindu thought, enlightenment is often described as liberation from temporal illusion, a realization of the eternal. Now, Christian mystics, too, speak of divine presence as timeless. While these are spiritual metaphors, they hint at a universal intuition that linear time may not be ultimate. Advanced alien minds might embody what human mystics only glimpse, an existence free from the confines of before and after. The contrast with human thinking is stark. Our cognition thrives on cause and effect reasoning. We design, plan, and hope because the future is uncertain. But for timeless entities, there would be no uncertainty, only structure. Their intelligence might resemble mathematics more than narrative, apprehending reality as geometry across time. To us, their actions might appear godlike interventions that unfold with precision, as if orchestrated in advance, but from their perspective, nothing is planned. Everything simply is. If such beings exist, their relationship to us would be as difficult to fathom as a three-dimensional creature's relationship to a two-dimensional world. We, confined to the line of time, perceive only one moment after another. They, existing outside linearity, would see our entire history as a completed whole. Whether they intervene, observe, or ignore us, their engagement would not resemble dialogue but authorship. To them, humanity might be less a story unfolding and more a sculpture already formed. The implications are unsettling. If alien minds are timeless, then our cherished notions of progress, choice, and destiny may be irrelevant to them. We may be performers in a play whose script is already known, watched not for suspense but for structure. And yet the thought also carries awe. To imagine timeless entities is to imagine consciousness unbound by fear of ending, unburdened by uncertainty, existing in a serenity beyond comprehension. For humanity, the challenge is not to prove or disprove their existence, but to recognize the limits of our imagination. Our narrative thinking is not the measure of all mind. Somewhere in the cosmos, intelligence may exist that does not think in stories, does not move in time, but dwells in present. To encounter such beings would not only challenge our science, it would transform our very definition of what it means. To be alive, are they already within us? When we imagine alien intelligence, we usually picture something external arriving in ships, sending signals, or watching from afar. But what if the frontier of alienness lies not in the sky, but in our own mind? Some theories suggest that consciousness itself may be linked to quantum process, entangled with time in ways we do not fully understand. If so, then perhaps what we call mind is already a host for alien-like structures, entities not separate from us but interwoven within us. Consciousness remains one of science's great mysteries. Neuroscience can map brain activity, tracing neural firing patterns and chemical flows, but the leap from matter to subjective experience, the feeling of being, is unexplained. This gap, sometimes called the hard problem of consciousness, leaves room for speculation that mind may not be reducible to biology alone. Quantum theories of consciousness, though controversial, propose that awareness arises from quantum events within neurons or microtubule processes sensitive to the deep structure of time. If true, consciousness might be more than computation. It might be participation in the quantum fabric of reality itself. In that case, our thoughts and awareness could already be shaped by temporal processes beyond ordinary perception. What feels like memory or imagination could be faint echo of non-linear time, whispers of structures that transcend before and after. From this perspective, alienness is not out there, but inside us, woven into the very act of perceiving. The contrast with external aliens is striking. When we think of others, we expect difference in form, strange bodies, unfamiliar technologies, exotic world. But internal alienness would be difference in function. Our mind might host processes that are not entirely ours, shaped by a deeper logic of quantum time. If consciousness is a bridge between biology and physics, then perhaps we are already participants in something larger, fragments of a cosmic intelligence expressing itself through us. Mystical traditions echo this idea. Many describe the self as an illusion, a mask worn by a deeper unity. Meditation and altered state sometimes dissolve dissolve the boundaries of individuality, revealing experience of timeless, interconnected, or presence beyond the personal. While often explained in psychological terms, such experiences could also be interpreted as glimpses into the quantum substrate of mind. What mystics call union with the divine might, in speculative science, be entanglement with alien-like processes already inside us. Skeptics warn against overreaching. Quantum theories of consciousness remain unproven, and critics argue that the brain is too warm and noisy for delicate quantum states to persist. Neural firing can be explained without. Invoking quantum mysteries and the temptation to connect mind to physics may reflect our desire for grandeur rather than necessity. From this angle, internal aliens are metaphors, not mechanism. The alienness of mind is simply the strangeness of subjectivity itself. Yet even without quantum leaps, the mind is alien territory. Split-brain experiments reveal that consciousness can divide, creating semi-independent selves within one brain. Artificial intelligence demonstrates intelligence without human form. Dreams generate worlds that vanish at waking, populated by figures who act with apparent autonomy. All of this suggests that alienness is not elsewhere but a constant companion inside the human condition. So, are they already within us? Perhaps not as literal extraterrestrials, but as structures of awareness we barely comprehend. If consciousness is tied to quantum time, then every human mind may be a portal into something vast and alien, a window into the deeper fabric of reality. The search for intelligence beyond Earth may ultimately circle back to the strangeness within the realization that we too may already be the aliens we seek. Who watches the watchers? For all the speculation about alien minds, temporal watchers, and consciousness woven into the quantum fabric, mainstream science maintains a far more cautious stance. At its core, science is conservative, not politically, but methodological. Claims must be testable, reproducible, and subject to falsification. Where imagination leaps, science demands evidence. This tension between wonder and rigor defines the current conversation about time, consciousness, and extraterrestrial intelligence. The prevailing position among physicists is simple: backward communication through time remains unsupported. Wormhole, closed time-like curve, and retrocausality make for elegant mathematics but lack experimental confirmation. Quantum entanglement, often miscast in popular accounts as a loophole for time-bending communication, has been repeatedly shown to transmit correlations, not information. Every attempt to use entanglement as a cosmic telephone has failed. The conclusion is clear: if temporal messaging is possible, it is not possible with the tools we currently understand. Biologists and neuroscientists are equally skeptical of exotic claims about consciousness. The majority view is that awareness arises from complex neural processes, not from mysterious quantum effects. Brain activity can be tracked, predicted, and even altered with increasing precision, all without invoking deeper physics. While the hard problem of subjective experience remains unresolved, most researchers prefer explanations grounded in biology. To them, theories linking mind to quantum mechanics are speculative at best, distractions at worst. Astronomy, too, leans toward restraint. The silence of the cosmos is not taken as proof of temporal watchers or hidden civilizations, but as evidence that intelligent life is rare, transient, or simply uninterested in communicating. The Fermi paradox. The question of where is everybody still drives debate, but the mainstream answer favors mundane explanations over extraordinary ones. Civilizations may collapse before they reach interstellar capability, or they may be too far apart in space and time for meaningful overlap. The absence of Dyson spheres, engineered galaxies, or clear techno-signatures supports the cautious view. Yet caution is not dismissal. Many scientists remain open to possibilities beyond current paradigm. Cosmology itself has repeatedly overturned old assumptions: the expansion of the universe, the existence of dark matter and dark energy, the reality of black holes, all once speculative, now foundational. The history of science warns against hubris. What seems impossible today may prove obvious tomorrow, given new data. Thus, while mainstream science does not endorse exotic claims, it also avoids absolute denial. Instead, it holds space for the unknown while prioritizing what can be measured. The contrast with human imagination is striking. Culture thrives on stories of contact, time travel, and consciousness beyond matter. Films, novels, and myths stretch boundaries in ways science cannot. Imagination fills the gaps left by evidence, creating narratives that speak to emotional and existential need. Where science hesitates, culture leaps, and those leaps, though not always accurate, often inspire the very questions science later pursues. The dream of flight preceded the airplane. The dream of the atom bomb preceded nuclear physics. Imagination outruns proof, but it also paves the way for discovery. This interplay defines our moment. Scientists remind us of limits, insisting that speculation is not evident. But imagination refuses shrink, pointing to mysteries that science has not yet solved. The nature of consciousness, the true structure of time, the possibility of other intelligence. Between these poles, skeptical caution and expansive wonder, humanity searches for meaning. Science's current stance, then, is not denial, but humility. It says, we do not know and we cannot yet test. For now, we treat extraordinary claims with extraordinary caution. Yet the history of science itself whispers, remain open. The universe has surprised us before, and it will again. The paradox of temporal observation. Observation is rarely one-sided. On Earth, to watch is also to be watched. Hunters stalk prey, but prey evolves to notice the hunter. Nations spy on one another, aware that their surveillance may itself be under surveillance. This reciprocity is natural. Awareness provokes counter-awareness. But what happens if observation is not merely spatial, but temporal? If advanced civilizations can watch us across time, then arises a paradox. In observing us, might we also be observing them? At first glance, the answer seems no. If their technologies allow them to peer backward, the flow of information appears one way, from our present to their future. We are exposed, they are concealed. Yet physics complicates this picture. Time is not a simple arrow, but a fabric. In relativity, the past and future coexist as coordinates in space-time. Quantum mechanics, with its entanglements and retrocausal interpretations, hints that cause and effect may loop rather than flow. If so, then their observation of us might not be isolated. It could generate echoes, feedback, or even mutual entanglement. Consider the analogy of a mirror. We gaze into it expecting to see ourselves, but the reflection is also a form of watching. The image alters our behavior. We straighten our posture, adjust our face, react to our own observation. If temporal watchers observe us, perhaps their very act of observation shapes the timeline, leaving imprints we interpret as anomalies, myths, or precognition. In this sense, their gaze is not passive but participatory, and if we notice those imprints, if our culture responds to them, then we are, in a way, observing them back. This creates a feedback loop. Watchers influence the watched, and the watched, in turn, influence the watchers. Prophecies, myths of gods, unexplained patterns in physics, these may be residues of such loops, glimpses of interaction across time. If so, the line between observer and observed blurs. We become participants in a dialogue even if we do not recognize the other voice. The paradox deepens when we imagine consciousness entangled with time. If minds are linked to quantum processes, then observation itself might not respect linearity. Their awareness of us could ripple backward, influencing how we perceive them in dreams, intuitions, or cultural archetypes. In turn, our responses might ripple forward, shaping what they see. Observation becomes a two-way street, not through messages, but through the structure of reality itself. Skeptics caution against overcomplicating. There is no evidence that temporal feedback loops exist, let alone that advanced civilizations engage in. Most anomalies have natural explanation, and the mirror analogy, while poetic, may mislead. Yet the paradox remains logically compelling. If they can watch us across time, then their act of observation is itself part of the timeline we inhabit. It cannot be entirely external because we are embedded in the same continuum. By definition, their gaze alters what it observes, and thus, we too observe the traces of their act. For humanity, the idea is both disquieting and empowering. If we are merely specimens in a one-way experiment, our role feels diminished. But if observation creates reciprocity, then we are not passive subjects but co-authors of the cosmic exchange. Even without technology to match their awareness, choices, and interpretations might echo across the loop. We shape the story as much as they do. The paradox of temporal observation, then, is not surveillance versus freedom, but asymmetry versus reciprocity. We may never know if advanced beings truly watch us, but if they do, the act cannot remain one-sided. To watch is always, in some sense, to be watched. Perhaps we all already participate in a dialogue across time, mistaking feedback for silence, echoes for emptiness, living with the mystery. At the end of all speculation, whether about temporal watchers, alien civilization, or consciousness entangled, with quantum time we arrive at a space that resists resolution, mystery. No matter how far physics stretches or philosophy questions, the ultimate nature of time, mind, and existence remains hidden. We cannot know with certainty whether we are observed, whether civilizations manipulate chronology, or whether our very thoughts echo alien processes within. But perhaps the absence of closure is itself the gift. Mystery deepens our search for meaning. Certainty offers comfort, but it can also narrow imagination. If science declared with finality that no intelligence exists beyond Earth, the cosmos would shrink into silence. If, conversely, proof arrived that we are watched across time, the enigma would collapse into explanation. Either outcome would resolve the tension, but at the cost of awe. It is uncertainty, the balance between knowing and not knowing, that fuels human creativity. Myth, art, science, and philosophy all thrive in the gap where questions linger. To live with the mystery is to recognize that meaning is not always found answered, but in pursuit. Ancient cultures gazed upward and told stories of gods among the stars. Modern scientists scan with radio telescopes, analyze anomalies, and model quantum paradoxes. Both gestures arise from the same impulse, a refusal to accept emptiness, a tool out yearning to weave ourselves into the larger tapestry of the universe. The persistence of the question, are we alone? Are we watched? Do we matter? Is itself part of what makes human. This does not mean surrendering to fantasy. Skepticism remains vital, grounding us in evidence and protecting us from wishful misinterpretation. But skepticism need not erase wonder. To doubt is not to dismiss. It is to hold space for possibility while demanding rigor. In that balance lies a uniquely human stance, cautious yet hopeful, rational yet imaginative. The cosmos may be silent, but silence is not absence, it is invitation. The paradox of our condition is that we crave answers even as answers may diminish us. Certainty can be claustrophobic, closing off the vistas opened by uncertainty. Mystery, by contrast, expands us. It forces humility, reminding us that our perspective is limited, our knowledge partial. Yet it also affirms significant, for to ask such question is to participate in the grand project of awareness itself. We may not control the gaze of others, but we control the courage to look outward and inward, to live as seekers rather than spectators. Whether or not watchers exist, the act of wondering transforms us. If they are out there, then our questions connect us to a wider community of mind. If they are not, then our search testifies to our resilience, the determination to find meaning even in solitude. If time can be bent, if consciousness is quantum, if myths are echoes of contact, then we are already part of something immense. And if none of these are true, the universe remains no less wondrous for our attempt to imagine. So we live with the mystery. We wake beneath stars whose silence both haunts and inspires. We invent stories, build instruments, debate possibilities, and dream of futures where the veil lifts, even if only slightly. The search is endless, not because it will succeed, but because it is who we are. In the end, certainty is not required. Or to live with the mystery is to embrace our place in the cosmos, not as beings who know all, but as beings who dare to. And in that daring lies the truest form of